2 to the x plus 3 to the x minus 4 to the x plus 6 to the x minus 9 to the x equal to 1, we should find x. For solving the problem, please subscribe and turn on the bell, like the video. So here we have 2 to the x, 3 to the x, 4 to the x. I can write it as, if we apply these power rules, I say it is 2 to the x plus 3 to the x minus. I write 4 as 2 squared x, 6 as 2 times 3x, and 9 is 3 squared x equal to 1. First one, I say it is 2 to the x plus 3 to the x minus 2. I can say 2 to the x, 2 to the 2x plus 2x times 3x minus 3. 2x equal to 1. We've applied these two rules. I can say 2 to the x plus 3 to the x. Here I can write it by applying this power rule. I can say it is 2x squared plus 2x times 3x. Last one, 3x squared equal to 1. Now consider 2 to the x as a, 3 to the x as b. So it will be a plus b minus a squared plus ab minus b squared equal to 1. Now, when we have something like this and we want to work with real numbers, one thing is to take all things to one side. For example, I take all things to the right side, will be a squared plus, let me write like this, a will be negative b plus a squared minus 2ab, sorry, a squared plus a squared. AB will be negative AB, negative B squared, B squared, and 1 is on right side, so we write plus 1. One important idea for solving these things is to change them, is factorizing or write them as sum of some squares. Since I want to write sum of some squares, I want to use this identity, but here we have negative AB. If we have a plus b equal to this, a minus b squared will be a squared minus 2ab plus b squared, because b will change to negative. You should memorize these two identities. But here I have negative ab. So I multiply both sides by 2, 0, negative 2a, negative 2b, plus 2a squared minus 2ab, plus 2b squared plus 2. At first, we consider 1a squared, 1 negative 2ab, 1b squared. I write them like this, a squared minus 2ab plus b squared. If you see negative 2a, you use, because we have 2a squared, I use a squared minus 2a. If I use here a minus 1 squared, it will be a squared minus 2a plus 1. Replace b with 1 here. I say a squared minus 2a plus 1. Here we have 2, so I consider one of them here. Also, I have 2b squared, b squared minus 2b here, minus 2b. 2, one of them here, 1 here. So right hand side will be this. If I apply this identity, I can say first one is a minus b squared, this one, a minus 1 squared, and this one, b minus 1 squared. And it's so much good. Why? Because each square is at least 0. There are real numbers. So when sum of some squares equal to 0, each of them should be 0. So a minus b should be 0. A minus 1 should be 0. B minus 1 should be 0. From this one, a equal to b. From this one, a equal to 1. Take 1 or add 1 to both sides. B equal to 1. But a and b were what? Here. A 2 to the x, b 3 to the x. A is 2 to the x, b is 3 to the x. From this part, we conclude x is 0. From this part, x equals 0. Also, a will be equal to b. So we conclude x has to be 0. Please don't forget to subscribe, turn on the bell, and like the video. Thank you.